Hello students, this is the new chapter for 10th class called coordinate geometry. Okay, generally we have three types of geometry. One is plane geometry, second is coordinate geometry, third one is solid geometry. Okay, solid geometry sometimes called 3D geometry, coordinate geometry called 2D geometry. This is plane geometry or D geometry. No need to mention D, just plane geometry. So this plane geometry already completed. Coordinate geometry also completed in foundation topic. Just I want to explain the coordinate geometry for only 10th class, means what is given the book that I will explain. Solid geometry also we discussed. Okay. Coordinate geometry or Cartesian geometry. Okay, a French mathematician René Descartes is invented coordinate geometry. He mixed algebra and plane geometry. Algebra plus plane geometry is nothing but coordinate geometry. So this chapter is invented by René Descartes, a French mathematician. René Descartes, that's why the geometry is called Cartesian geometry. Okay, what happens in geometry I will explain. In general geometry, a dot followed by A will read as point A. But in coordinate plane, every dot should followed by ordered pair. Ordered pair means two real numbers separated by a comma and enclosed small bracket is called ordered pair. What this ordered pair says, I will explain now. Okay, listen all of you. So in this plane, two mutually perpendicular real numbers are taken as shown in figure. Two mutually perpendicular real number lines. Here 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 1, 2, 3, minus 1, minus 2. So total plane is divided by 4 equal regions here. These two are two mutually perpendicular lines. Intersecting point is denoted by O. Okay, on this straight line we have positive real numbers, this straight line we have negative real numbers, here positive real numbers, negative real numbers, such a way that two real numbers are arranged on a plane. So this plane is now called coordinate plane. General plane nothing is there. Now here two mutual perpendicular lines are taken on a plane. That plane is called coordinate plane or Cartesian plane. Okay, now this is Cartesian plane. Okay, so what happened? These two mutually perpendicular number line real numbers divide the whole plane into 4 regions. This is one region, say Q1, and the second region Q2, third region Q3, and fourth region Q4. What I told, in this plane every point should followed by ordered pair. For example, this point followed by ordered pair A comma B. So what is the meaning of ordered pair? This ordered pair shows the position of this point with respect to these two mutually perpendicular lines. What this ordered pair says, what this AB says about this point. So this ordered pair says this point is A units from the vertical line and B units from horizontal line. Vertical line and horizontal line. In generally, horizontal line named by x-axis and a vertical line named by y-axis. So what I can say, this x-axis and y-axis are perpendicular to each other on the coordinate plane. Okay, so what the ordered pair saying, that this point is A units from y-axis and B units from x-axis. Units from distance. Now do one thing, from that point draw perpendicular on y-axis and draw perpendicular on x-axis. Okay, should observe none. Measure this length, this should be B units. Measure this length, that should be A units. That's why ordered pair A comma B says that this point is A units from y-axis and B units from x-axis. Actually, in ordered pair A comma B, A is called x coordinator, B is called y coordinator. X coordinate saying that how much distance that point is from y-axis, and y coordinate saying that how much distance is that point from the x-axis. Okay, ordered pair. Abscissa and ordinate. Sometimes A is called abscissa and B is called ordinate. Okay, so this is the nature. So actually we need to use a modulus symbol to distance, because that point may be in the second or maybe in the fourth quadrant also. For example, this point is taken as minus A comma B. This point is A units from x and B units from x axis, A units from x axis. That's why mod of minus I can say that this is mod of B. That's why ordered pair A comma B means this point is mod A units from y axis and mod B units from x axis. So this is one thing. Okay students, listen now. Okay, so by using this definition, for example, here a dot is taken. What is the ordered pair followed by this dot means I can see the 2 comma 3, 2 comma 3, here 2 comma 1, 2 comma 1, 2 units, this also 2 units, this point is 2 units from y axis and 1 unit from x axis. Okay, for example, this point is taken, what is this? 1 comma 2, observe 1 comma 2 here, 2 comma 1 here. What is the meaning of that? 1 comma 2 not equal to 2 comma 1. In general, ordered pair A comma B not equal to ordered pair B comma A. Their positions are different, no? Okay. For example, take this point. What is this? That is important thing. So this point is minus 3 comma 1. Okay, take this point and what happened? This point is minus 2 comma minus 1. Why? What is the use of minus 3 comma 1? Actually, minus 3 comma 1 is 3 units from y axis only. This negative symbol saying the left hand side of the y axis, and 1 unit from x axis, and positive saying that above the x axis. Here 2 comma minus means this point is 2 units from y axis only, left hand side of the y axis, and minus 1 unit from y axis, and minus symbol saying that it is below the x axis. Like that, for example, this point is taken. This point is nothing but 3 comma minus 1. 3 units from y axis, right hand side of the y axis, 1 unit from x axis, below the x axis. What is observation here? So what is observation? Every point in Q1 of the form plus comma plus, x coordinator plus y coordinator plus, minus plus, here minus minus, here nana plus minus. This is one thing. One more thing, this is x axis, no? What are the ordered pair followed by this dot means I can say 4 comma 0. 4 units from y axis and 0 units from x axis, 0 units from x axis, because it is on x axis. That's why every point on x axis of the form some x comma 0, where x is any real number. So take this point and what is the 0 comma 1, I can say 0 comma 1, 0 units from y axis, 1 unit from x axis. That's why every point on y axis of the form 0 comma y, where y is any real number. One more thing, what are the coordinates of this point? 0 comma 0 can say. This is called origin or starting point to this geometry. Based on this point only, these two lines, these two intersecting lines are oh no. Okay, so what are the coordinates of 1 and 0 comma? That's why this is called origin, starting point. Okay, this is the structure of coordinate geometry. Okay, so this plane is called coordinate plane. These are called axes. This x axis, y axis. Okay, this plane is called Cartesian plane. Okay students, next one is distance between any 2 points on xy plane. So this is 1 minute. So students, this is our xy plane. 2 dots are given on a plane. 2 dots are given. While joining these 2 dots, you get a line segment. How to find the length of this line segment? This is the concept for us. So for my mathematical convenience, the 2 points are taken on a x axis and the line segment not parallel to any one of the axes. If if this line is parallel to x axis, then what happened? Y1 equal to y2 only. But what is my assumption? x2, x1 and y1, x2, y2 are distinct. That's why this line segment not parallel to any one of the axes. If AB parallel to x axis, automatically y coordinate should be same. If the line is parallel to y axis, automatically x coordinate same. What is my assumption? x1 is not equal to x2 and y1 is not equal to y2. That's why I got a line which is neither parallel to any one of the axes. Now I want to find distance between these 2 points. What we should do, Nana? We need to draw perpendicular here. Say this is P. So from here need to draw perpendicular. Say this is Q. So observe what is OP. OP means this one only, no? This length and this length are same. This length saying that x1. So OP x1. OP equal to x1. I wrote here. OP equal to x1. Next OQ. OQ means this distance. OQ means x2. OQ is equal to x2. Okay. AP means y1. AP means y1. Somewhere I know. Okay, no need to write. AP equal to y1. Somewhere I mentioned. Okay, AP equal to y1. QR. Okay. Where is that QR? Okay, AP or QR both are. What they did, perpendicular dropped. So this is taken as R. So AP y1 only. QR also y1 only. QR equal to y1. Okay. So similarly, AR also you can find AR. AR means what, Nana? OQ minus OP. AR and PQ are same. So AR equal to OQ minus OP, that is x2 minus x1. I want BR, BR means BQ. BQ means y2 minus this length, that is y1. So this length is y2 minus 1, this length is x2 x1. This is a right angle triangle. Right angle hypotenuse square equals sum of squares of other two sides. So AB square equal x2 minus x1 whole square plus y2 minus y whole square. AB equal root over x2 minus x1 whole square plus y2 minus y whole square. Hence the distance between 2 points A and B is taken as root over x2 minus x1 whole square plus y2 minus y1 whole square. By using this formula, you can find the distance between any 2 points on the coordinate plane. Between any 2 points, say A x1 y1, B x2 y2 given. Distance between these 2 points is taken as root over x2 minus x1 whole square plus y2 minus y1 whole square. Okay. So distance from origin to any point, for example, this is x comma y. So root over x square plus y square is the distance from any point to origin. Okay. Distance formula completed. Now application of distance formula. So some problems are given here. We need to solve these problems. Students, listen, Nana. So first one, find the distance between the following points. Some points are given. Just you want to find the distance. I want you. Second problem I want to explain, Nana. So how to write step, that is important. Let A equal to minus 5 comma 7. B equal to minus 1 comma 3. Do one thing, student. Let down you write this is a x1, this is y1, say this is x2, this is y2. AB you want to find. First of all, you write formula in examination, that is x2 minus x1 whole square, or x1 minus x2 whole square also same. That is not a big problem. But we got a result as x2 minus x1. That way, in that way, you need to remember. So x2 minus x1 whole square or x1 minus x2 whole, both are same. That is not a big problem. So this is the formula. Just substitutions. x2 means 3, sorry, x2 means minus 1, minus half minus plus 5 whole square, plus y2 means 3, minus 7 whole square. That is equal to root over, this is 416, yeah, plus this is also 4, minus 4 square 16, that is equal to, yeah, root 32, 16 2s are 4 root 2 units should write. Therefore, distance between these 2 points is 4 root 2 units. Okay. So this is problem number 2, students. Find the distance between these two. Okay. Verify whether these 3 points are collinear or not. So collinear points definition. Collinear points. Okay. 3 are more than 3 points lies on a straight line, then the points are known as collinear point. Important, students, listen. 2 points are always collinear, no? That is not a big problem. Through 2 points only you can draw unique line. If 3 points are given such a way that the 3 points lying on the same straight line, the 3 points are called collinear, otherwise non-collinear. Now I can say that here A comma B comma C are collinear point because these 3 are lying on the same straight line. 3 or more than 3 points lies on a straight line, then the points are known as collinear points. Okay. So how can you check whether given points are collinear or not? By using a distance formula. Okay, students, listen here. For example, this is straight line, here A, here B, here C, somewhere C. So in my diagram, ABC are collinear. So AB distance plus BC distance equal to AC distance. For example, they are not non-collinear. For example, they are not collinear. Here B, here A, here C, non-collinear. They will form a triangle. If 3 points are non-collinear, always they will form a triangle. So here AB distance plus BC distance not equal to AC. No, AB plus B should be greater than AC. Triangular property. AB plus BC should be greater than AC in this diagram. But here in this diagram, what happened? AB plus BC equal to AC. What is the meaning of that? If AB plus BC equal to AC or sum of any two distance equal to third distance, we can say that the given points are collinear. If AB plus BC equal to AC, then you can say the A comma B comma C are collinear in that order. Just for example, sometimes you got AB plus AC equal to BC. What you can say, they are collinear only, but not in this order, ABC order. Okay, so A should be in between B and C. B, AC are collinear. Okay, so collinear and non-collinear. If 3 points are non-collinear, always they will form a triangle. So here third question, check whether they are collinear or not. I mean, just we need to find, first point is taken as A nana, second one is taken as B, third one is taken as C. Just find AB, BC, AC. First AB, BC. AB equal to, directly I want to write, I don't know, 2 minus 1, 1, plus 3 minus 2, 4, root 5. Next I want to find BC directly. BC minus, what is this? Minus 2. Okay. Minus 2, 16. Yeah, minus 1 plus 16. That is equal to 16 plus 16 root 32. Yeah, 32 means 4 root 2. I think this is correct only. 1, 5, 2, 3. 2 minus 1, 1. 5 minus 3, 2. Okay. So AC I want. AC. AC equal to minus 2 minus 1, 9. Minus 1, this is 5, no? Okay, correct only. 5, 36. Minus 36. So what it gives, Nana? 36 plus what is that? Is 45. 45. 9 5s are 3 root 5. This is root 5. I think BC, I made a mistake. BC 2 plus 2, 4, 16 plus 2 minus half minus 1, 16. Correct only. So what is the meaning of that? Sum of any two are not equal to other one. See, observe. These 3 root 5, root 5. Addition 4 root 5. If root 5 is there, okay. But 4 root 2 given. That's why sum of any two not equal to third one, means that given 3 points are not collinear points. Next, check whether these are vertices of an isosceles triangle. Just a triangle is given. Vertices are given. A equal to 5 comma minus 2. B equal to 6 comma 4. C equal to 7 comma minus 2. We want to check whether they will form isosceles or not. Means any two of sides should be equal in length. Okay. Just find AB and distance formula. 5 minus 6, 1 plus 36, that's called root 37. BC 7, 1 plus 4, 5, 6, 36, 37. Completed here only. AC root over 7 minus 2, 4. Yeah, plus 0. That is called root 4 actually. Don't write. Actually 2 you can write, but that is not a big problem. Therefore, AB equal to BC. So, given triangle is an isosceles. Okay. Okay. In a classroom, 4 friends are seated at the points A, B, C, D as shown in figure. Jarina and Funny walked into the class, and after observing for a few minutes, Jarina asked Funny, "Don't you notice that ABCD is a square?" Funny disagree. Using distance formula, who is correct and why? Just the point A given, so I want to enlarge the diagram to identify the point A. Observe all of you. So first of all, I want to identify A here. That is, what is that, Nana? This is 1, 2, 3. 3 comma 1, 2, 3, 4. 3 comma 4. A equal to, I want to use another color. A equal to 3 comma 4. Yeah, somewhere B here. B means 6. 6 comma 7. B equal to 6 comma 7. Yeah, where is C? Here C. C equal to 9 comma 4. D equal to, here D, that is 6 comma 1. Okay, students. So now I want to reduce this. So what you got points I will write again. Fifth problem. A equal to 3 comma 4 and B equal to 6 comma 7, C equal to 9 comma 4 and D equal to 6 comma 1. Okay. Now we want to check whether they will form a square or not. Just we want to find AB and BC and AC and AD. Okay. What is their argument? Square. So what is the definition of a square? First of all, you want to show that all four sides are equal length. That is one thing. If all four sides are equal, it may be rhombus also. No? Every rhombus is not a square. Every square is called rhombus, but every rhombus is not called a square. One more thing you need to verify, that is diagonals are equal in length. In rhombus, diagonals are not equal in length. That's why do one thing: A, B, C, D. Find AB, BC, AC, AD, AB, AC, BD also. If all the four sides are equal in length and diagonals also equal, then only you can say that it is a rectangle. Okay. Find AB. I want to find directly AB. 6 minus 3, 9. Plus 9. 18. 3 root 2. What is that? BC next. BC 6 minus 9 plus 9 3 root 2. CD should find CD 9 minus 6 9 plus 9 3 root 2. AD should find AD 6 minus 3 9 plus 9 3 root 2. All sides are equal. It may be rhombus or square, not yet decided. So AC should find AC diagonal 9 minus 3 9 minus 36 plus 0 6. BD should find BD where is that? BD, yeah, 6 0 7 minus 36 6. Okay, so ABCD is a square. Okay. Yeah, students, what happened? Our problem number 5 completed. Sixth problem. Show that the following points form an equilateral triangle. You people can complete. Now just find AB distance, BC distance, AC distance. All the three are equal. Then you can say that is an equilateral triangle. Okay. Next, prove that these taken in order are the corners of a parallelogram. 4 points are given. How to check they will form a parallelogram in this stage, because just distance formula concept only completed. Do one thing, students. Every square is a parallelogram, every rectangle is a parallelogram, every rhombus also parallelogram. Okay, that's why do one thing: find AB length and DC length if they are equal. Find AD length and BC length, they are also equal. So AB equal to DC and AD equal to BC, directly you can conclude that it is a parallelogram. Show that taken in order the vertices of a rhombus, and also find area. So this is interesting. Rhombus. Student, every square is a rhombus. But every rhombus need not be a square. Okay, student, find AB distance, BC distance and DC distance, AC distance. If all lengths are equal, so directly you can say that is a rhombus. It may be square, no problem. Every square is a rhombus only. That's why just try to find all the lengths. If all the equal, directly you can conclude that it is a rhombus. That is one thing. After that, how to find area? So we know the formula for area of a rhombus of D1 D2. Area of rhombus half into D1 into D2. Half of product of diagonals gives the area of the rhombus. Just to find AC length, next BD length. Okay, half into D1 D2 gives the area of that rhombus. You people can complete all these problems. Okay. Name the type of quadrilateral formed, if any, by the following points, and give reason for your answer. Here, same. Okay, observe, students. Quadrilateral is given when it is become parallelogram. All two pair of opposites are parallel, it's called parallelogram. That is the definition. But by using distance formula, you can't check those two lines gives parallel or not. just distance. Try to find this length and this length. If these two are equal and these two are equal, then you can conclude that it is a parallelogram. If not, so it is not a parallelogram. It may be a trapezium or general rectangle. Okay, if all the sides are equal, it may be just you can call it is a rhombus. It may be square also. Later we'll discuss. Later we can find how. After that you find diagonal lengths. In rhombus diagonals are not equal length, but in square diagonals are equal length. Okay. Rectangle. How to prove rectangle? Rectangle same. No. First of all, prove that it's a parallelogram. This length equal to this and this length equal to this, and show that diagonals are equal in length. In rectangle, diagonals are equal in length. In parallelogram, diagonals are not equal in length. Okay. You people can complete. Find the point on x-axis which is equidistant from these 2 points. Interesting question. Here 2 points are given. One is say a2 comma minus 5. Say another point b is minus 2 comma 9. One point is given here some p on x-axis, so that this distance should be equal such a way that p should find. Obviously p is some x comma 0 only, no, point on x-axis. Let p equal to x comma 0. PA should be equal to PB, or PA square should be equal to PB square. X minus 2 whole square plus 25 equal to x plus 2 whole square plus what is that? 2 comma 9, 81. Okay, or x square plus 4 minus 4x plus 25 equal to x square plus 4 plus 4x plus 81. What happened here? X square get cancelled. 4 and 4 get cancelled. You transfer that side. 8x plus 81 minus 25. 5, 6. Here, what is this? Here 7. 56. So x equal to minus 7. Please cross check all these calculations. Sometimes I will make mistakes. X equal to minus 7 I got. What I can say? P equal to minus 7 comma 0. Okay. Next problem. 11th problem. If the distance between this and this is 10, then find a just distance formula equating to 10. So we'll get modulus. Sometimes we'll get sometimes we will get two values of x. Take care of that. Find the value of y for which the distance between this point and this point is 10. Same model. Find the radius of the circle whose center is this and passing through. Center is given as 3 comma 2. Passing through minus 5 comma 6. What is the meaning of the just distance between these 2 points? Only the radius of the circle. Draw diagram in examination and say this is O. Say this is A. You should write OA equal to distance of the OA equal to radius of the circle, and find the distance. Whatever that is the radius. Okay. Can you draw a triangle with these vertices? Give reason. Interesting problem. Just check whether they will form they will collinear or not. If they are non-collinear, then we can draw a triangle. If they are collinear, we can draw a triangle. We can't draw a triangle. We can draw, but whose area equal to 0. That is not treated as triangle in general. Okay. Just what 14th problem is saying that we want to verify whether the given points are collinear or not. Collinear, we can't draw a triangle. Non-collinear, we can draw a triangle. Reason is that one only. 15th question. Find the relation between x and y so that x comma y is equidistant from these 2 points. Okay. Px comma y is equidistant from 2 points. What is one of the point is minus 2 comma 8. Another is minus 3 comma minus 1. So this is A. This is PA equal to PB given. PA square equal to PB square. X plus 2 whole square plus y minus 8 whole square equal to x plus 3 whole square plus y plus 5 whole square. So x square plus 4 plus 4x plus y square plus 64 minus 16y. X square plus 9 plus 6x plus y square plus 25 plus 10y. Students, now some calculations. X square, y square cancel. Here 4x, here 6x, transfer this side, minus 2x. Here 16y, here 10y, transfer this side, minus 26y. Constant terms, no, this is 68, this side 68 plus 68. This side 25, that is 34, minus 34 equal to 0. Simplify, what we will get? There is a relation. Next one is section formula. Students, listen now. AB is a line segment. P is any point in between A and B. Then you can say that P dividing AB in the ratio of AP is to PB. Or another words I can say P dividing AB internally in the ratio of AP is to PB. We can write AP by PB. If say this is, for example, this length is M, this length is N, then you can say that AP by PB equal to M by N, or AP is to PB equal to M is to N, or another words I can say P dividing AB internally in the ratio of M is to N. One thing. Next one is, this is AB, a line segment. P is on extended AB. Okay, in this case you can say that P dividing AB. P dividing AB externally in the ratio of AP is to PB. Important Anna. P is an extended AB or extended BA. Not in between A and B. Then you can say that P dividing AB or BA externally in the ratio of AP is to PB. For example, this length is M, this length is N. I can say that AP by PB equal to M is to N. Okay. So, yeah, AP is to PB. Vector in sense AP is to BP means minus we will take now. AP by BP means you can take minus. I am not using that concept here. Just AP by PB equal to M is to N. So, in this section, if for example coordinates of A are given as x1, y1, coordinates of B given as x2, y2, P dividing AB in the ratio of M is to N, how to find the coordinates of P? One situation internal division, another situation external division. How to find the coordinates of point P? These type of concepts already completed in our foundation. Just I want to explain, students, listen here. I don't want to waste your time. Okay. So formula is given. This is the diagram. Here A, here B. So I will draw again, no problem. Just here A given, whose coordinates are x1, y1. Here B given, whose coordinates x2, y2. P dividing in the ratio of M is to N. Now we want to find coordinates of P. Okay. How you did? We draw perpendicular, and this is say R. Perpendicular, say this is S. Perpendicular, say this is T. Perpendicular, and this is Q. Perpendicular, this is C. Just to, you can find this length of this line segment, length of this line segment, length of this line segment, length of this line. That's not a big problem. After that, these two triangles are similar triangles from AA similarity. Here 90 degree, here 90 degree, and these two are parallel, transversal. These two angles are equal. That's why these two are similar triangles. That I wrote here. Two triangles are similar. From that we will get the required result. This is the result. What is the formula? mx2 plus nx1 by m plus n comma my2 plus n y1 by m plus 1. Okay, students, listen now. This is A, x1, y1. Say this is B, x2, y2. P dividing the ratio of m is to n internally. Then coordinates of P here derived, already derived, no, that is not a big problem. mx2 x2 plus nx1 by m plus n, comma my2 plus ny1 by m plus. By using this formula, you can find the coordinates of P internally. Okay. If instead of this you write minus in between them, what you will get? That is called external division. P is an extended AB or extended BA. So, to find the coordinates of P, you should use the formula mx2 minus nx1 by m minus n, comma my2 minus ny1 by m minus n, provided m is not equal to 0. Okay, this is total derivation. Note, special case, if m equal to n. M equal to n means what? And for example, here this is B, here P, this is M, N. M equal to n, P should become the midpoint of AB only. No? If m equal to n, p becomes the midpoint of n. Put n equal to m1 equal to m2 equal to 1. So what we will get now here, x2 plus x1 by 2 comma y1 plus y2 by 2. This is the formula for finding midpoint of aligned segment AB, or sometimes called midpoint formula. This is called midpoint formula. Okay, one example problem. This is A, this is B, this is 4 comma minus 3, this is 8 comma 5. Yeah, a line segment P divided internally in the ratio of 3:1. We want to find coordinates of P. So this is taken x1 y1, this is x2 y2, this is m and n. First of all, we want to write the formula mx2 plus nx1 by m plus n, comma my2 plus n y1 by m plus n. Three into 8 plus n means 1 into 4 by 3 plus 1, comma 3 into 5 plus 1 into minus 3 by 3 plus 1. 24 plus 4 by 4, comma, what is this? 3 times of 5, 15. 15 minus 3 by 4. That is equal 28 by 4, comma 12 by 4. That is equal 7 comma 3. These are the coordinates of P. In this way you can find the coordinates. Clearly here mentioned internally. That's why use internal formula. Okay.